Hello, here's today's class, a little late, but I think we'll manage. I'm going to talk about polymorphism today. Polymorphism is considered one of the most important parts of an object-oriented language. All it means is that we're not going to define things as we compile it, as we take it and translate it. We're going to, some things are going to be defined as we run it. That is, there are going to be more than one possibility, and depending on how we use a particular word, it's going to have a different meaning. Now, to start that off, I'm first going to do a simple case, and then we're going to build on this one. I put it here because trying to get it over by typing it takes too long. So I'm going to look at a class, regular polygon. Regular means all the sides are the same size, same length. It has a length, it has a set length, and a get length. Then I define three subclasses. A triangle, and in the triangle, I'm going to print the circumference 3 times the length. In the rectangle, I'm going to print the circumference 4 times the length. And in the pentagon, I'm going to print the circumference 5 times the length. So we have a normal setup of a parent class and 3 children classes. Now in the main, I'm defining a vector, and the vector will have pointers to a regular polygon. I'm calling that vector shapes. But now, look what I do. I have SH here, and SH is a pointer to a regular polygon. And yet, when I create a value to go into SH by using new, I use the triangle constructor with 6 as the length. That can be done because a triangle is a subclass of SH. So a pointer to a regular polygon can point to a triangle. The same thing is true for these 3. And then I'm using the new Python-like for loop to go through shapes and print the get length of each shape. Now I'll compile that, and I'll run it, and you'll see we get 6, 7, and 8, which is the get lengths. So everything seems fine there. Now, I want to define a new function. I want to define in each of these subclasses a function void print circumference. I had it there before, but I didn't use it. Now let's try using it. So I'm going to go down here, and I'm going to try to write, let me just write it here. Okay, I'm going to try to write x point to, and I'm going to see if I can write print circumference. And I probably misspelled it a couple of times. I think that's right. And now when I do it, I get an error message. Here's the error message I get. There's no such member. Because the member is defined for the subclasses. It's not defined for the actual full parent class. But I'd like to have it in the parent class. So how could I do that? This is where the idea of an abstract or pure data type comes into place. So I'm having trouble getting rid of this. Give me a second. There it is. Now I can get rid of it. Move it over to the side here, where it was a minute ago. What I'm going to do is I'm going to go up into the parent class. And I'm going to define a new item in the parent class. The new item is going to be a virtual void function, circumference, it'll still print circumference, pardon me. And it's going to be equal to 0. And I don't need this line regular polygon anymore, because it turns out I can't define a polygon. When I have any function or anything that has the virtual in front of it and an equals 0, this means that data type cannot be instantiated. I can't have an object of that data type. It is an abstract data type. And the only way I can have objects that are pointed to by that is if I instantiate the children classes. So now when I go down here and run it, I'm going to get headaches again. This happened when I was preparing this. The thing just did not want to do it. Let me see if I can find out what's wrong up here. Void print circumference. I don't have it spelt properly. That's what's the matter. There we are. Now I don't think I'm going to get any errors. I'm still getting an error. Now we'll see what happens, because it worked before. It should work now. We'll see. And it worked. I got successful. And now if I run it, pardon me, if I run it, you see that I get the proper function for each of the polygons. That's what I mean by we don't decide which function to use until we're running the program. When I wrote the program like this, I didn't have any idea whether I was going to apply circumference to a rectangle or a triangle or what. But when the program was actually run, it picked the correct one. It picked the one I needed. So when the pointer was to a triangle, it picked this one. When the pointer was to a rectangle, it picked that one. When the pointer was to a pentagon, it picked that one. That is called dynamic binding. It means we don't decide what the function is until we actually need it. Now that's a little strange, perhaps, but it works nicely, and it's just what we want. It means that I can define a virtual function, an abstract class that has a function in it, but you won't know what the function is until I actually use it. The function is print circumference, but there's no print circumference for the regular polygon. It doesn't have any meaning until we get down to the children classes. And depending on which child you choose, the function has a different meaning. In one case, it prints for this try. In another case, it prints for this rec. It's not the same function. It's three different functions, but they all can be gotten to by the void, by the virtual function up in regular Polygon. The word virtual is used all over the place in computer science. You'll come across it many more times. What it means is basically it's there, but it's not there. We act as it's there, as if it's there. We can use it, but really it's only like a hanger for something. It's only like a placeholder. We'll take care of it later. Now I'm going to print the file that has this out to the Sakai, and I'm going to post this shortly. So see you later. Have a good weekend. Bye now.